I love blending electronics with design, and this project is one of my favorites. It looks like a classic thermometer, but it is powered by an ESP32 microcontroller with a tricolor e-paper display. The case is 3D printed using wood filament, giving it an authentic vintage look. While it has an old-school charm, a real-time dashboard that is hosted in this device allows you to track temperature, humidity, and pressure with a clean, modern interface. Let me show you how I built it. If you follow my channel, you know how much I love vintage devices. When I discovered these tricolor e-paper displays, I immediately envisioned recreating the elegant simplicity of classic thermometers. The e-paper technology was the perfect fit. E-paper displays provide excellent contrast, making them easy to read, and they consume power only when updating. So here is the result: an analog-looking thermometer that uses the latest electronic components available to makers. I love simplicity, and as Leonardo da Vinci once said, simplicity is the ultimate sophistication. That's why I designed this thermometer to display only the current temperature. I think this simplicity makes it look beautiful. The temperature reading updates every 5 minutes, but if we need more frequent and detailed information, the web dashboard provides real-time monitoring of temperature, humidity, and barometric pressure. You can check live readings from your phone or computer, whether you are at your desk or in another room. The data is stored locally, so nothing leaves your network, ensuring full privacy. With 48-hour logging, you can also look back and see how temperature, humidity, and pressure have changed over time, making it easy to spot trends in your environment. With this, we have the best of both worlds, an elegant gadget with a wealth of information. The total component cost is under $40, making this an affordable do-it-yourself project. Let's review the parts needed. We just need 3 parts: an Inkplate 2 board from soldered, a BME 280 sensor for the readings, and a micro USB breakout board. One of the best things about this build is how simple the wiring is. You only need 4 connections. The BME 280 sensor measures temperature, humidity, and barometric pressure, and it uses the I2C interface, so it is very easy to work with. I soldered 4 wires to the board and connected the sensor to them. We have to connect power and 2 more wires to SEL and SDA pins of the board. Now let's see the software we need. In order for the project to compile, we need 3 libraries: the Inkplate library for the display, the Adafruit BME 280 library for the sensor, and the Arduino JSON library. You can download all the libraries directly from the Arduino IDE. The software for this project is organized using object-oriented programming. Each functionality has its own class, making the code base more modular and maintainable. So we have the sensor class, which handles communication with the BME 280 sensor, retrieving temperature, humidity, and pressure readings. Then we have the sensor data class, which manages data storage and history, allowing the system to keep track of environmental readings over the last 48 hours. Finally, we have the display class, which is responsible for rendering information on the e-paper display. This modular approach makes it easy to adapt the project. If you want to use a different display, you only need to create a new display class. Similarly, if you want to use a different sensor, you only need to modify the sensor class. The rest of the code remains unchanged, ensuring seamless functionality. You can find a link to the code in the video description. It is completely open source, and you are free to expand it with additional functionality. I would love to see what you create using this code as a starting point. To draw the thermometer on the display, we use a bitmap image as the background. Then a red rectangle is drawn on top to show the temperature, with its length adjusting based on the current reading. As the temperature rises, the rectangle grows. As it falls, it shrinks. I didn't spend a lot of time optimizing the power efficiency of this device since it is designed to remain plugged in. However, I did implement some power-saving measures where possible. For example, the e-paper display only updates when necessary. If the temperature reading changes but the difference isn't large enough to visibly affect the display, it won't refresh. This means that even though the device reaches the temperature every 5 minutes, the display only updates when a noticeable change occurs, reducing unnecessary power consumption. I won't go into further details on how this code works or its exact functionality. If you are interested in learning more, I have created a detailed 10-page PDF explaining what each file does, and you can find the link in the video description. In the main project file, we need to set two values, the SSID and password of our Wi-Fi network. This allows the board to establish a web server for the dashboard. Additionally, if you prefer imperial units instead of metric, set the metric variable to false. And that's it. The code is now ready to be uploaded to the board. The device now displays the temperature on the e-paper screen and has also set up a web server. If we check the console, we can see its IP address. By entering this IP address into a browser, we can access our dashboard. Cool! We can now see the current temperature, humidity, and barometric pressure readings. However, the graphs are not yet visible since there is no historical data available. It will take 48 hours for the graphs to fully populate with historical data. So I left the device running over the weekend, powered by a power bank, and used a power meter to measure its energy consumption. 48 hours later, I am back at the office. The power bank still has charge, and the dashboard now displays all the data collected over the weekend. The code ran without crashing, proving the system's reliability. Notice the significant drop in temperature while I was away. Now, let's check the power consumption. Over the past 48 hours, the project consumed 2,400 mAh of power. This means the device requires about 1,200 mAh per day to operate, making it impractical to run on battery power. The high power consumption is due to the web server running continuously and waiting for incoming requests. If we don't need the dashboard, I believe we can modify the project to run on battery power for several months by optimizing power consumption. To improve the aesthetics and functionality of the device, I decided to enclose it in a custom 3D printed case. I slightly modified the original 3D files provided by the board manufacturer, making two key adjustments. First, I added a small cutout at the back to expose the sensor, ensuring more accurate environmental readings. And second, I created an opening for the USB mini breakout port, allowing for a more convenient power connection. The built-in USB port for programming and power is not positioned in a way that allows the device to stand upright. You can find a link to the files in the video description. Next, I soldered two wires from the USB breakout board to the V-in and ground pins of the board. This modification allows us to power the board conveniently from this connector. After assembling all the components, the project is complete. I really like how it turned out. The finished project looks fantastic on my desk. The e-paper display provides great contrast, giving the thermometer a classic analog appearance. I hope you enjoyed this project. It is one of my all-time favorites. I have always wanted an e-paper weather station with this design. Since no commercial product like this exists, I decided to build my own. We are fortunate to live in an era where we can create anything we envision in just a few days. Thanks to the internet, we have access to endless knowledge and the ability to connect with like-minded individuals. If you enjoy my work and want to follow my journey, subscribe to my channel to stay updated on future projects. Now, if you like this project, I have another you might enjoy, a larger, full-color e-paper weather station. Click here to check it out.